Good evening, Dr. Cortez. Welcome to my presentation on the analysis and reflection on student data from one of my tests. A little bit of background information before I get into the analysis. So the test that I chose was a test that I just gave recently. It was for a college prep chemistry, and it was on acids and bases. And so the data I'm looking at is for my 5th period class. And then just a little bit of demographic information for my class. Fairly standard. The gender percentages is a little bit different than most of my classes. Usually I have a majority females in my classes. So this is a little bit different than that. But everything else is fairly standard for a class that I have at my high school. The standards that were being assessed are under the Gwinnett AKS, the Academic Knowledge and Skill Standards. And so standard 5 is just kind of a catch-all in terms of the acid-base properties, and then more specifics with the models in 5G, pH and percent dissociation, and hydronium concentration in 5H, neutralization reactions in 5I, and then nomenclature in 2H. So these were the ones that were being assessed for this. The first thing that I did is just run some descriptive statistics. So I used the Excel template that you provided, but I also used SPSS to get some of the graphics because I was just a little bit more familiar with that, having worked in a quant class right now. So I'm using SPSS a lot, so it's a little bit more familiar to me in terms of producing these types of statistics. And so the mean for this was 76.54. The median was 78. The mode was 78. We had a second mode up at 94 as well for that one. The standard deviation of 13.7. And then a skewness of negative 0.438. That negative value means that it's skewed towards the upper end of the distribution, which for a unit test where the student should be showing mastery, I'm okay with that skewness value for this assessment. First thing I did is do a little bit of analysis of the standards, and so I just kind of used the average or the percent correct for each of the questions and analyze it by standard. And so I plugged it into just SPSS and produced this box and whisker plot here. So things that jump out, the first thing is that standard 5 had the lowest, or 5G, sorry, had the lowest average of all of the standards. That is the acid-base models. It's one of the first things that we cover in the unit right after nomenclature, and so it is essentially almost 5 weeks from when we learned that to when we assess because of the spring break in there. And so I'll talk a little bit more about that and the timing when we get into the implications at the end, but that would be something I would need to address this standard here. And then the other two that had low values that I would want to look at would be standard 5I and 2H. So 5I would be the nomenclature standard. Sorry, 5I is the neutralization standard, and 2H is the nomenclature standards. Nomenclature is the first thing we cover in the unit, how to name acids and how to write their formulas. And then this is arguably the hardest standard that we do, the neutralization and having them predict products from a neutralization reaction. It's something that we do after spring break, so it's more familiar for them, but it is usually one of our more difficult questions and something that we usually have them analyze a lot more in terms of data. So when I get into the actual item analysis, the first thing I looked at was the percent correct for each of them. And so I used SPSS and got the percent corrects for these. So this first column, this mean column, would be the percent correct. So questions that stood out, the first ones would be number 15 and 41. They had very low percent corrects. So 15 had 0.35, 41 had 0.46. So those would be the ones that I would want to look at and see what the students were doing. And then there were 3 of them that actually had only 50% of the students get correct. Questions 12, 33, and 45. So those would be ones I would want to look at as well. Ideally, according to the presentation, for these types of assessments with 4 answer choices, students, the ideal value for percent correct is about 67%. I wanted mine to be a little bit higher than that because it's a mastery test at the end of a unit, and so I was hoping to see values a little bit higher than that. And then there were 2 questions that actually had 100% correct, numbers 22 and 43, so they don't show up. SPS throws out questions that have 100% correct. And so those would be ones I would look at to see if they were too easy, if they were really truly assessing something that the students should know, and maybe something that I could go back and reword if I needed to for that. So I just wanted to quickly look at each of these questions and kind of talk about what I saw, and then I'll get into other types of analysis. So analysis of question number 15, the most missed question. The biggest thing that I saw is there was a typo on this one. So you can see in letter B where it should have been the correct answer, cation is misspelled. That could have had an effect. I don't know for sure. I'd have to talk to students about why they chose A over B, because A was the predominantly picked question. I think only a few students picked C for this one. So I would have to talk to the ones that picked A, why they picked A over picking B, if they chose it because of the typo or if they actually thought it was A for the answer. So that would be the one that I would need to go back and actually talk to students to figure out, and then going forward, I need to make sure there's not a typo on that question. The second question, number 41. So there were a lot of questions on the test where they were given this prompt at the beginning, and then there was either a property or an example of a substance, and they had to tell me if it was an acid, a base, or if the property was that of an acid and a base, something like conductivity. And so looking at this question, the students were guessing on this one. The reacts with carbonates was the prompt, and so it should have been an acid. But the students were essentially half and half on this. Almost 50% picked A, almost 50% picked B. And so this is one that I need to go back and remediate. And something that I could maybe do is use a real-world example. So talking about carbonates and, bring in the presence of like Tums. And talk about Tums are made out of calcium carbonate, and those are things that we eat when we have issues with the stomach acid, causing indigestion or an upset stomach. And so that could be something that might help them make a real world connection, and that could help better understanding of, it's the carbonate substances that are reacting with the acid when we consume a lot of those chewable antacids. The next question was converting from a name to a formula. 50% correct, and then the students that missed it essentially picked A or D. So the students that picked A knew that it, they saw the sulfuric and they used the sulfate ion. And the ones that picked D saw the hydroprefix and knew that it needed to be a binary acid, so no oxygen in there, but they were not balancing the oxidation numbers. And I'll talk a little bit more about that later when we look at comparing high performers to low performers. The next question, number 33, they actually had to identify two different properties, and so one would have been how these substances change in the presence of phenolphthalein, the acid versus the base, and then also how they affect a conductivity apparatus. And so the students either identified one or the other property correctly. Not a lot of people picked A, but they either knew it was an acid because of, or they either knew that it was weak because of the dimly lit conductivity apparatus, or they knew it was a base because of the phenolphthalein, and then the ones that got it correct knew that it was a combination of those. So the most picked answers were B and C if they were incorrect. And then the last one that I would want to analyze in terms of just percent correct was number 45. And number 45 would be a DOK3 question that was a little bit more complex, and they had to analyze the data here. And so being at 50% correct, this one I'm okay with being. This should be a question that separates the high performers and the low performers for this. It's a little bit lower than they recommend, and so maybe I could possibly reword and make it a little bit clearer. But it was also a more complex question, so I would expect it to be a little bit more missed. The two questions that I would look at in terms of percent correct, because it was a very large or very high percent correct, 100%, would be number 22, which is on the screen now. That is, they just had to identify which of the solutions would have equal amounts of hydrogen and hydroxide ions in terms of their concentration. And so they should have known that equal amounts would have been a pH of 7, and that would have been pure water for this one. They know about water being 7. Not a lot of them knew at the beginning of the unit that meant that there was equal amounts of hydrogen and hydroxide ions. So I'm okay with this question still being on here because it is assessing something new. And then this one here was another one of those property questions. So the example was lemon juice, and they identified that it was an acid. So that was 100% correct as well. So maybe I could use a different example of something that maybe a little bit less common in terms of acidic compounds they would come into contact with, so something like aspirin or vinegar. Something that they don't remember, citric acid would be an acid in terms of the citrus fruit there. The second thing I would look at would be the discrimination factor, and so I used SPSS as well for that. So really we're doing a reliability analysis when we're looking at this correlated item to total correlation, or corrected item to total correlation. So it's this column that I'm looking at in terms of the discrimination factor. SPSS throws out anything that had 100% or a discrimination factor of 1, so 22 and 43 are thrown out on this one as well. So the values here were a little bit different than what the Excel template provided, but they allowed me to analyze the same way. So ideally you want something above 0.2. The ones that drew my attention were the ones that were negative. Those would be the ones that I would want to go back immediately and look at and see why and who was missing those questions to see if there's something I can do to adjust my assessment. So looking at those questions, number 42, had a discrimination factor of negative 0.156, so this was the lowest discrimination factor, although it had a very high percent correct, 92%. So only 2 students got this wrong. Both of those students were high-performing students, but only 2 got this one wrong. And what I noticed is that one of my students was one of my ELL students. And so a possibility for this question is that this is too long of a prompt for that student to comprehend. And so I need to break it down and make it simpler for them to understand so that they don't have to read all this and then figure out what they need to do. And so I think that's going to be a common theme as we go through this, is that the wording could be better for my ELL students and make my assessments more ELL friendly, as we learned a couple of modules ago. The next question is the same question that showed up with the complexity or the difficulty analysis. So this formula for what is the formula for hydrosulfuric acid had a discrimination factor of 0.103. So this would be something that I need to remediate. If it has a low value in terms of the difficulty and also a low discrimination factor, it's something that they don't understand that well. So that's something that I need to go back through and remediate. And it seems like they had a harder time with the binary acid than they did with the oxy acid, so just using a polyatomic ion for the anion part of the acid. So that's something that needs to be addressed, and I think it would benefit them to have an assessment before spring break, because this is when we learned this was before spring break, so it's a long time to remember all the nuances in terms of nomenclature. So that's something that I could do going forward. And then the last 3 that I would look at were all negative values, but I guess higher negative values or lower negative values. They were closer to 0. And all 3 of these were missed by my ELL student. So he did well, but the ones that he missed have these low values. And so this would be something that where, again, 34, I can reword this one to make it more accessible to ELL students. And then I think for 31, this phrase conductivity apparatus, maybe provide a picture of what it is, because we used it in class and we called it a conductivity apparatus, but that is a large word for my ELL students to understand it. And so it would be an idea to give a picture of it so that they would be better to make the connection to what we talked about in class, and that could help with the answering of that. The next thing that I did is I divided my class into subgroups, and so I did it based on their overall test average up to this point. And so we'd had 3 tests on moles, stoichiometry, and solutions, and so I divided my groups based on their test averages. And so the cutoff was really essentially 78%. That allowed me to get almost 50-50 split of the class, and there actually was a big gap between my high performers and low performers in terms of their averages. So 78 was the lowest for my high performers. The highest for my low performers was actually, I think, a 73% on their test average. And so it seemed like a good place to split the group. So just to kind of see if it made sense, I ran a little bit of analysis using SPSS. So I got the mean for the 2 different performers on this test. So the high performers had a mean of 85, whereas the low performers had a mean of 66. And then to see if that was significant, I ran an independent sample t-test for these 2. So I got a t-value of 4.7, and then I had a significant value of 0. So these 2 groups are significantly different. And so I think that justified the splitting of my 2 groups into these by my categories of 78% here. So I wanted to look at 5 questions on these 2 subgroups and see how they did compared to one another. So I picked a couple of the questions based on just the content that they were assessing. So number 14 was a DOK3 question. It had them analyze what happened in the lab. And so what I would expect to see would be my higher performer students did better than my lower performer students on the more complex question. And so you see that is the case for this. So overall, the class got 53% correct, whereas my high performers were at 71% and my low performers were down at 33%. One thing that was interesting to me is that it was actually better discriminating performance among my low performers in terms of a 0.42 discrimination factor, whereas my high performers actually was a negative value. So I had high performers, the highest performing students in the high performer category actually got this one wrong. And so that would be something I would want to talk to them about why they chose that. And that's something I usually do the day or 2 after the test to see which ones they picked and why they went through that. The next question I picked because it was one of the standards that was more missed, which was neutralization, that 5I standard. And so they had to predict the products of an acid-base reaction. So the whole class got 77% correct. My high performers got 92% correct, whereas my low performers only 58%. Again, I see the same thing where it was better at discriminating between my low performers than it was my high performers. Only 1 student missed it in my high performer category. So it being a smaller sample size, only 14 students, that's going to affect the discrimination factor a lot more for that one. So that would be a reason why I see this value here, this negative 0.3. The next question I picked, because it was also a low standard, it was nomenclature. So I picked the one working with an oxy acid. And so you can see for this one that 61% got it correct, 85% got it correct for my high performers, whereas only 0.33% got it correct for my low performers. I believe this was the biggest differentiation between percent correct for my high performers and my low performers. Nearly 52% difference between the two. For my high performers, what I noticed is that they either knew that it had to have the phosphate ion and they didn't balance their oxidation numbers. One student did that, and then one student knew that to balance the oxidation numbers, but they didn't use the phosphate ion. They just used the phosphorus in terms of it would have been hydrophosphoric acid. Whereas with my low performers, I noticed that 6 of them, so 6 of the 12, so 50% picked this one here. So they knew they had to have the phosphate ion, but they didn't balance the oxidation numbers. That's something that I see over and over again this semester, is that students that usually do poorly on tests don't remember how to write formulas. So they can't write a formula when they're trying to find the molar mass of something. They can't write a formula when they're having to balance an equation for stoichiometry. So that skill that we learned first semester never really carries over. And so if they can't write an equation or they can't write a formula, they struggle with when we start to apply that. And that is evident with this one as well. They don't remember to balance oxidation numbers. I picked this question, number 16, based on the data, because what I saw is that my low performers actually did better, 75% compared to the 57% for my high performers. And so I wanted to see what might have been the case. And so my high performers that got it wrong picked A, which was a pH meter. And so I think what threw them off is this word tool. So it asks for a tool used to demonstrate the presence of an acid base or neutral solution by changing color. I think they saw tool and thought back to the lab that we did where we were measuring the pH using a pH meter, and the tool is a tangible thing for them, and so that's why they picked that question. So maybe something I could reword going forward to help with understanding of that a little bit better. So maybe get rid of that word or reword the question in such a way where that is not the emphasis, and they see that tool and then immediately pick the pH meter for that. And then the last question that I wanted to analyze compared to the two groups would be the only kind of calculation that was required for this. We no longer require them to calculate hydrogen concentration from pH or vice versa. So all they have to be able to do is tell me like how much more acidic something is. So they're using the pH scale as that log scale, that base 10 scale, and knowing how the concentrations change as we move from one pH value to the other. And so 65% of the whole class got this one correct. My high performers got 78% and was actually really good at discriminating, 0.6 value for that. And then 50% of my low performers got it correct. So overall, not too bad. And they had a 0.3 discrimination factor as well. What I noticed is that my high performers knew that it had to be a base 10 of something. So it had to be a factor of 10. So they either picked C or D, and they maybe have done their math wrong when they went from a difference of 3 for the pH. And so they computed that wrong. Whereas my low performers, I had students that were picking over here in A and B, which they should not have been picking if they realized it was a base 10 scale. And so that would be something that I would want to address between the two groups and spend a little bit more time with the students that are a little bit lower performing and stress that it cannot be one of these values here because of the way the pH scale works, being that logarithmic scale. So implications that I noticed as I came across and looked through the different things. The first thing is I need to be better about wording of my questions. I do not feel like my assessments are the most ELL friendly, and we talked about it a few modules ago. That's something that I need to look at going forward, and then looking back over the assessments I've given so far this year, I need to try and simplify some question strands or provide diagrams as a supplementary material to help them understand. So 2 of my 3 EL students scored very low, and then the one that scored higher, my higher performing EL student, he was the reason why my discrimination factors were low for certain questions, because he was one of the only ones missing the question, and it could have been because of his understanding of the question itself. And so that's something I need to do going forward, is to reword my questions and look back for I guess to be more ELL friendly. So it's something I could also pass to my ELL instructor and see what her comments are on with if she could give me suggestions on how to make my questions more accommodable to them. Second thing that I thought about as I was looking at this is I think my students would benefit from a splitting of the content. It is a long unit just by the nature of where it falls in the calendar, with spring break in the middle of it. And so the standards that they did poorer on, the acid-base models and the nomenclature, that's the first stuff that we learn. And so it is, 4 or 5 weeks before they are assessed on a summative test on these, and they have a week of break in the middle. And so that I don't think benefits any of the students, especially my lower performing students who did poorer on those types of questions. So I can possibly give an assessment the week before spring break on everything that we had covered at that point, and then when we get back, have a small assessment on the topic that we cover afterwards, which would be usually strong versus weak acids and bases and percent dissociation, and then neutralization. And then the last thing, just general remediation. A couple things need to be retaught. And so it'd be something that I could go over with acid-base models and nomenclature. Those are the two big things that needed remediation. And so that could be something that if I assess before spring break, I could remediate again as we get into neutralization, especially with the nomenclature. As they're writing neutralization equations, we can practice more of the nomenclature aspect of that. So writing acidic formulas and naming acids. For the acid-base models, that would be something that we could get into dissociation equations. And so as we get into equilibrium, and getting into dissociation equations and kinetics in general, this would be something that we could bring back up, looking at the acid dissociation constant and the base dissociation constant in terms of the equilibrium values for that. So that'll do it for my analysis. Thank you for listening. I will attach a link to this through YouTube, but I will also upload all of my Excel files and my SPSS outputs and my data files for you to look at, Dr. Cortez, so you can see exactly how I did my analysis for these different things. Thank you.